obviously the mathematical framework will talk about a function. So the mathematician said that we need to give a number to the bundle. Okay, so any bundle A gives me a utility of say A. Any bundle B, it gives me the utility of bundle B, small b. If A is greater than B, then we will say that the bundle A is preferred over the bundle B. If A is equal to B, we will say that the bundle A is indifferent, or he likes the bundle A and B equally. And if, for example, A is less than B, then the bundle B is preferred over the bundle A. So the mathematician put this very beautifully into something he called the utility function or the preference function. Okay, wherein they said that let's attach numbers to each bundle and that will help us out. So please understand that if I increase my X or Y, my utility should increase. So as X increases, the utility value increases. This will ensure that more is preferred over less, because if my utility value will increase, then obviously my value has increased, and hence I will be preferring the bundle having more X or more Y over the bundle less X or less Y, right? So X increases, the utility increases, transitivity. So if I have another UC, which gives me C, if A is greater than B, B is greater than C, then obviously I'll automatically have A greater than C. That means that transitivity will also hold. Completeness, any bundle will have a particular value assigned to it. So if every bundle has a particular value automatically assigned to it, completeness is automatically satisfied. Each and every bundle will have a value. Hence, I can easily see which is greater, less, or equal. Therefore, those bundles will be preferred, indifferent, or inferior. And convexity. Convexity is something which is also a desirable property, which makes the utility function something called quasi-concave. Okay. Now, quasi-concave as a property, we will study in detail when we go into mathematics. But just understand it in this way, that quasi-concavity is a property which mathematically tells us that the functional value of some sort of a average between two bundles A and B will always be greater than equal to the minimum of the utility of A and B. Okay. So if A and B are indifferent, then the minimum is also the same, but their average is greater. The utility value of the average, the function, the utility function is say U. The utility of the average of A and B is preferred over the utility that you derive from the bundle A or the bundle B, which is what is convexity. Okay. So quasi-concavity is a property which says this mathematically. So it's basically putting the convexity property into a mathematical framework. Okay. So the utility function, in order to satisfy all these properties, number one, the utility function will always be giving us a value. So completeness is done. Any greater value will always be greater over all the other values. So x0, y0, x1, y1, x2, y2. So if this is say giving me a utility value of 5, this is giving me a utility value of 4, this is giving me a utility value of 3. So since 5 is greater than 3, automatically the transitivity thing is holding. More is better. So as my x is increasing, my utility also increases. So automatically I'll get this more is better, and the utility value will also be higher. Convexity, the average of the bundle AB, the utility that I derive will be greater than the utility that I get from A or B separately. This is called a quasi-concave utility function. So these are the properties which the economist got back from the mathematician, that these are a few properties that it should satisfy. Assume that you've not done a consumer behavior ever till now. So look at this from a completely neutral frame of mind. Don't have any preconceived notions, okay? Because this is a very different way of explaining consumer behavior than what each of you would have experienced in your college. So that's about the utility function which the economist got back. But the economist and the mathematician sat together and they talked about and they discussed a few concepts. From there, as someone was asking, from there arose the concept of a cardinal utility function versus an ordinal utility function.